This is lab number 8, and lab number 8 what we will be teaching you, like I said in lab 7, that we will be teaching you demonstration of peristaltic pump using Arduino. So, what exactly peristaltic pump? You see, when you look at the drug delivery module, or you want to flow the media, there are several kind of pumps. One pump is called syringe pump, where you use syringe, and whatever the media is there in the syringe, as soon as the syringe as soon as the media is over, you need to refill that syringe, right. But in the case of peristaltic pump, you have a reservoir, you have an inlet and you have an outlet. So, the you can use as a continuous closed loop system. What does that mean? That if you have a if you have the microfluidic chip, in the inlet of the microfluidic chip you can connect the outlet of the peristaltic pump. From the outlet of the microfluidic chip you can connect the inlet of the peristaltic pump. And be very careful what I am saying. You have a microfluidic chip has an inlet and an outlet. The inlet of the microfluidic chip should be connected with the outlet of the peristaltic pump, and the outlet of the microfluidic chip should be connected to the inlet of the peristaltic pump. What will happen? That means that if my reservoir, which is within the peristaltic pump, has a media, then I can flow the media through the peristaltic pump, through the outlet to the inlet of the microfluidic chip. It will flow through it, and from the outlet of the microfluidic chip, that media will come back to the inlet of the peristaltic pump. So, how can you run this peristaltic pump? How can you control the peristaltic pump? Because peristaltic pump can be used to control from 0.1 microliter per minute to several microliters per minute, or in fact in some cases few ml plus per minute. Now, this is extremely important pump, because we can mimic the in vivo situation, where in some of the cases your drug will diffuse into your tumor at a rate of 0.1 to 1 micrometer per second. How can you exactly replicate that kind of environment in the in vitro platform? In vitro is where you are checking in the laboratory, alright, and you are so for example, drug screening, you want to flow the drug with 1 microliter per second. How can you flow? You can use syringe pump, or you can use the peristaltic pump. But like I said, if you want to flow it for 48 hours, the same media, once the syringe is over, you have to refill it, right. So, you cannot have a closed loop system in that case, while in the peristaltic pump you can have a closed loop system. So, that is the advantage. It can be used for a lot of applications, including immunotherapy. So, just focus on that particular aspect, and I will see you before the next lab class. Bye.
Welcome to the Sensors and Actuators course. In today's session, we will be discussing about an actuator that is called as peristaltic pump. So, there are water pumps. Pumps are devices or actuators that are used to move a fluid from one point to another. Okay. So, we use different type of pumps, maybe centrifugal pumps, peristaltic pumps, etc. Okay. We will be showing demo of one of it. Okay. So, there is the pumps can be classified into different categories, okay, positive displacement pump as well as centrifugal pumps. Okay. So, peristaltic pump is type of a positive displacement pump. So, you must have discussed about positive and positive displacement pump as well as centrifugal pumps in the previous lectures by the professor. So, I will be showing the demonstration of peristaltic pump, which is a positive displacement pump now. In the screen you can see two pumps. This is a 12 volt peristaltic pump over here, and this is a costly peristaltic pump for microfluidic applications. You must have seen the one of this kind of peristaltic pump as part of the lab videos. Okay. These peristaltic pumps are positive displacement pumps, and they are used for very precise applications, especially in microfluidics, drug delivery and other things, where the flow has to be controlled very accurately. Okay. So, we have a bigger peristaltic pump which are like costly as well, but at the same time they can regulate the flow in the rates of milliliter per hour and also, which is kind of very minute volume of fluid that is being pushed, and this is a higher volume displaced as well as 12 volt motor. Okay. Now, I will show you how a peristaltic pump works. You can see here in a GIF image, okay, you can see that the fluid will come through this port. Okay. So, it will come over here. So, what we have is a rotating roller kind of thing, okay, and in that rotating roller itself we have some small different wide rollers also you can see. So, what happens is this is the casing of the motor or the peristaltic pump, and there is a flexible tube over here. So the water or any fluid that is to be pumped will be coming over here, and what happens is when the roller rotates, this roller will come and push the fluid within the tube between the wall here and the roller, and push it to the other end. Okay, that's how the pumping of a peristaltic pump works. So this is a positive displacement pump. That means that the fluid will move only in one direction. Okay, so this is a positive displacement pump, and this is called the peristaltic pump. Okay, this process, this flow process is called as peristaltis. It's present in even human bodies. Okay, so this is how it works. This is the working of peristaltic pump. I have a peristaltic pump like what you saw in the image previously. So this is a small 12 volt peristaltic pump. I will open up and show you how it looks like inside. This is the flexible tube that we talked about. So this will be compressed. If we give the input fluid here, this tube will that fluid will be sucked and pushed in, and the output will come through this tube. Okay, the output will come through this tube and input will come through this tube, and you can see that is just nothing but a DC motor only here. Okay, so the DC motor is what is rotating that roller that I have shown here. Okay, so you can see that there are rollers here. So you can see that the tube is over here, and this is the casing between which the tube will be pressed against. Okay, and you can see there is a motor shaft. There is a motor shaft, and what happens is there is a mount for the rollers like this. This is not exactly what like what you saw in the GIF, but this is a different model. So there the rollers are fixed in different ways. This is one of the design. So I'm just putting the thing over the roller. Okay, now if we give power supply to the motor, this roller unit entirely will start to rotate. Okay, now the tube that is going to come over here will be compressed. You can see the tube is being pressed against and it has deformed, but it will still work. So this is the internal construction of a peristaltic pump. It's nothing but a DC motor, but with a different construction, a flexible tube, an outer casing to hold the flexible tube, and the rollers attached to the DC motor. So I'm just putting it back. Okay. Okay, so this is how a peristaltic pump is. I will demonstrate you how we are going to use the peristaltic pump. As I already said, peristaltic pump is nothing but a DC motor when it comes to its working principle. So we will be using the same circuit that we used previously for the DC motor and the same code that we used. Okay, so I will be showing the demo with that code as well as circuit. So you remember this Arduino code, right? It's the same code that we used for the motor. So I have used the serial communication. Then pin number 2 and 3 are connected to the motor driver. Over here it is the pump that is being connected to the motor driver now. Okay, and I have connected a potentiometer to the analog pin A0. The same process, we took the analog value from the potentiometer, we print it also so that we can see it on the serial plotter. The value y will be stored with the value of x by 4, so that we can adjust the range from 0 to 1023 to 0 to 255. Then using the analog write 2, y, I am controlling the speed of the pump, and here it is grounded, the other terminal of the pump. So by adjusting the potentiometer, we will be able to adjust the flow rate. Okay, now we will see the circuit at once. So as it's the same circuit that we used previously. I have the mega board, I have the potentiometer connected, I have the motor driver L29 and A10, and the peristaltic pump I showed you. And here is a peristaltic pump that is connected to the circuit the same way as the motor driver was the motor was connected to it. So this is the DC motor in the peristaltic pump, this is the tubes. Okay, So this is the power supply. You can see that the tube here, one of the tube is going to this empty vessel and the other one is going to a vessel with the water. I am going to switch on the power supply now here, DC power supply. So since I have already uploaded the code, you can see that the pump is starting to operate and the pump is pumping the water. See, you can see here. The water is going from here and going to and falling into the vessel. Okay, this is how a peristaltic pump works. You can see that water is not falling continuously. It's falling in not continuously but at discrete intervals. This is because you must be remembering that peristaltic pump is not continuously pushing water. It will push water in the tube for a while and then the roller will lose the contact. It will come again. So there is a small gap, that's why it's kind of pulsating and not continuous. Okay. So this is how a peristaltic pump works. I hope you understood this thing. So this is one of the pump that we use very commonly, mainly because of the fact that it is very accurate and consistent. You can see that the water level is increasing, right? And if I switch that cables now, you can see that no longer water is coming because the motor or the pump is pumping water in the opposite direction. But you can see bubbles coming because now the air is being pumped. So the peristaltic pump can even pump air because it's just a positive displacement pump. Okay, a centrifugal pump cannot do this, and it's self-priming. This one, the peristaltic pump, since it's positive displacement, it is self-priming. You can see the bubble coming. But in case of a centrifugal pump, you have to prime it before use. It is self-priming. See, even if air is in the tube, it will start pushing the water out. See, it's coming again. So it's self-priming. Okay. So this is how a peristaltic pump works. So thank you.